Welcome to OOTO TV, the out-of-the-office investigation from the past into the future of marine navigation and autopilot technology. This time we're discussing requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation.
It is a massive undertaking, Skipper, truly.
It really is.
We are essentially drawing the blueprint for the next generation of global navigation tool systems that must perform perfectly everywhere from, say, the Panama Canal.
Right out to the middle of the Atlantic, yeah.
Exactly.
And because that full title, well, it's quite a mouthful, isn't it?
It is a bit, yes.
So we're calling it the RS for short. And our mission today, really, is to break down the critical framework that defines it.
Okay.
We'll be looking at the required technical architecture, the necessary communication protocols for real-time data flow.
Crucial stuff.
And, maybe most importantly, the human factors that govern how safe and effective these systems actually are in practice.
Right. So let's start with that foundational structure, though. If the RS is the house, what are the pillars holding up the roof?
Well, the scope of this undertaking is just staggering. And to manage that complexity, the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation must be clearly defined in a step-by-step manner to meet three primary categories: audience needs, technical requirements, and safety regulations and restrictions for travel.
That structure is absolutely vital because, you simply cannot treat all vessels in all regions the same way. It just doesn't work.
Exactly.
And I must also point out that the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation vary by region, size, and type of vessel, and local laws and situations, weather, events, and tradition. It's incredibly diverse out there.
That necessity for variation is, well, it's fascinating when you dig into it. For instance, the safety equipment a vessel has to carry, like GMDSS, that's the Global Maritime Distress and Safety System, it's entirely dependent on the specific A1 through A4C areas it usually trades in.
Right. So the spec itself actually shifts depending on where you operate.
Precisely.
And it shifts based on the vessel itself, too, right?
Yeah.
And the regulations of the ports it enters.
Absolutely.
You take propulsion design, for example. Solutions like Shottle's Y-hybrid for azimuth thrusters, they offer these flexible design paths. It allows a shipping company to potentially reduce the size of the main diesel engine and maybe supplement that with electric power.
And why would they do that?
Well, to meet specific, often regional zero-emission requirements, and emission control areas, ECAs.
Ah, okay.
So the RS has to account for these really specific environmental compliance mandates. It's in complex fast.
It really sounds like a global balancing act. So shifting focus a bit now from the hardware and the regs, let's talk about the crew, the people actually using these systems.
The audience needs, yeah.
If we're designing the ultimate tool, we really have to ask, what features are required for marine navigation and piloting systems for both inshore and offshore global navigation to provide a modern and high-quality experience for the user?
Well, fundamentally, the user wants clarity and speed, right? Modern systems need powerful digital visualization.
Makes sense.
And while the 3D environment is, very natural and effective for representing complex data,
It feels intuitive.
it does. But the RS must mandate that 2D views are still supported. You need that continuity and familiarity for many users.
The overall goal here is simple, isn't it? Reduce cognitive burden.
That's the key phrase.
The IMO's e-navigation concept, it really focuses on ensuring that the user needs take precedence, especially at that digital human interface.
Right. We want the technology to almost fade into the background.
So the seafarer can focus 100% on the critical stuff, safety, the mission itself.
And that speaks directly to the human factor element, which,
Why?
well, we find it so compelling. We need systems that encourage PONO.
PONO, that's the Hawaiian concept.
Yeah, meaning achieving harmony or doing what is right. In the context of bridge resource management, BRM, the RS has got to require tools that actually improve the usability of the working environment. Make it work for the team.
That's the critical link, I think. When you analyze incidents like the NTSB's report on the El Faro sinking,
Tragic.
it often highlights how systemic issues, problems with the system or procedures can get mislabeled as simply human error.
Yeah, that's a real danger.
If the system itself is chaotic or counterintuitive, it just raises stress levels, it inhibits effective communication between the crew.
Exactly. So the best navigation RS should inherently support effective team communication. It should help prevent crew negligence from ever being the go-to explanation.
We need that harmony, that PONO on the bridge.
We do. Okay, moving now into the core machinery. The nuts and bolts.
The technical side?
Yeah, the required technical elements are what enable this global performance. So let's ask, what are key technical elements for implementation, requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation integrated into the bridge navigation station for both small and large vessels?
Okay, well, the modern integrated bridge system, the IBS, it's really a network, isn't it? Not just one single device.
That's right. It's all connected.
So the RS mandates seamless data fusion from the entire suite of equipment. You've got the gyro compass, providing that stable heading reference.
Essential.
The autopilot, which manages course keeping through, basic proportional control and lead mechanisms.
And rudders and things like that.
Exactly. And the speed log, often using the Doppler principle to give really accurate speed over the ground, sometimes dual axis for drift angle too.
And you can't forget the echo sounder, often using a frequency around 50 kilohertz for better deep water penetration and maybe a wider beam. All these raw inputs, plus things like radar P, GPS, maybe even Lorenzi still in some places, and the automatic navigation and track keeping system, or ANTS.
You're listening to OOTO TV with research by author Paul Bulow.
All of that has to feed into the ECDIS, the electronic chart display and information system. That's the heart of it.
Yeah, the ECDIS is central. And that real-time awareness you get from integrating all that data, that's where the RS truly shines.
It is, which leads directly to the next critical requirement for global operation, doesn't it?
It does, and that is the absolute necessity of current up-to-the-minute information. So requirements specification for marine navigation and piloting tool for both inshore and offshore global navigation incorporates existing databases of charts, maps, noting passages, channels, obstacles, depths, traffic, weather, and updates maps and course in real time using satellite and real-time data from the boat sensors of GPS, depth, speed, currents, fuel, and desired course, and ETA.
Phew, that's a lot of data streams.
It is.
And the backbone of this whole system is the ECDIS using electronic navigational charts, or ENCs.
Right, the vector charts.
Exactly. These are vector data based on the IA S57 standard, and they're referenced directly to the global WGS 84 datum. So it's standardized.
And the ECDIS does the heavy lifting with those charts.
It does. Route planning, route monitoring, constantly checking against the charted depth and issuing grounding warnings based on the vessel's draft. It's looking ahead for you.
And what about other traffic? Collision avoidance.
Well, for that, the AIS transponder systems are absolutely mandatory now. The RS requires AIS to receive and broadcast that crucial real-time info.
Like ship's heading, course, and speed over ground.
Destination ETA, all derived from an integrated GPS or DGPS receiver and broadcast over a VHF radio link. It's constantly talking to other ships.
Okay, so you have all these components, all these sensors, the ECDIS, but they all rely on communication, right? Connecting the vessel's own sensors to global data sources.
Absolutely. Which brings us to the next big question. Can users connect to both integrated sensors and connect to databases through Starlink satellite and VHF analog and digital transmission, as well as other radio frequencies that deliver real-time weather and location navigation data systems to integrate and use library data to relay time update, new geographic region, and new weather data for marine navigation and piloting tool for both inshore and offshore global navigation?
The short answer is yes, they have to be able to. The RS requires multiple layers of resilient communication.
Redundancy is key.
Totally. Satellite systems like GPS, GLONASS, they're foundational for position data, obviously. But for that two-way safety-critical data, the stuff certified for GMDSS.
Like distress messages.
Exactly. Inmarsat-C provides that crucial messaging capability, and it also supports things like safety net services for broadcasting maritime safety information to vessels in a specific area.
Okay. And closer range.
Well, for short-range operations and distress signaling, VHF is indispensable. It supports the AIS data exchange we mentioned, and also GMDSS digital selective calling, or DSC.
Right. And we also see the use of MF, medium frequency, for transmitting things like differential GPS corrections to improve accuracy, and even the LF, the low frequency band, for quite long-range ground wave communication. Yeah. That can sometimes reach over 1,000 kilometers.
Impressive range.
Yeah.
But internally on the bridge itself, all these different electronic boxes from different manufacturers, they need a common language, don't they?
They absolutely do. Otherwise, it's chaos.
And that's the critical role of serial data communication standards. Like NMEA 0183, that's pretty much the lingua franca of the marine electronics environment.
Yeah, you see that everywhere. Alongside others like RS-232 and RS-422, they ensure all the sensors and displays can actually talk to each other reliably without errors.
So getting that data flowing correctly is non-negotiable.
Fundamentally. Okay, so finally we turn to that third pillar of the RS, safety, oversight, and the mandate for continuous adaptation. It can't stand still.
No, it certainly can't. And the entire global maritime safety framework, as we touched on, is really built around GMDSS, that network designed for distress alerting and search and rescue coordination.
Using satellites like COSPASSER-SAT for EPR alerting.
Right. The RS is fundamentally defined by this overarching safety mandate. Everything has to serve that purpose, ultimately.
And yet, interestingly, we always seem to circle back to the human element, don't we? The things we established in the first section.
It's unavoidable.
We need effective bridge resource management, BRM. But it's inherently more complex, perhaps, than aviation's crew resource management, CRM.
How so?
The NTSB noted this in the El Faro context, that power differential on ships can be quite significant. It can make it harder for a junior officer to effectively challenge a commanding master, especially during a high-stress crisis situation.
That's a really critical point, and it's exactly why the RS must drive towards high-reliability procedures. Organizations are really emphasizing now that marine pilot refresher courses prioritize clear checklists and standard operating procedures, SOPs.
They're not just bureaucracy, are they?
Not at all. They are essential risk management tools. They mitigate those human factors by standardizing complex maneuvers, especially in congested or difficult waters. Take the guesswork out.
You're listening to OOTO TV with research by author Paul Bulow.
So, given that the environment, the weather, the traffic, the regulations, it's all constantly shifting, the RS itself has to be a living document. It can't be static.
Makes sense.
Therefore, requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation are updated and evaluated on an ongoing basis to incorporate needs and desires for new features and benefits and changes to existing regulations and requirements for marine travel.
And we see this modernization happening visibly in things like inspection systems, right?
You do.
The shift to SIRE 2.0, for instance. It replaces the old paperclip boards with a much more dynamic assessment model using intrinsically safe tablets.
So they can use specialized software.
Exactly. To conduct real-time inspections. It moves the whole process from just static checks to a genuinely dynamic safety assessment during the inspection itself.
And remote technology is now playing a bigger role too, isn't it? Directly influencing safety oversight.
Hugely. DNVGL, for example, used camera-equipped drones to conduct its first remote offshore survey on the semi-submersible Sea of Scandinavia.
Wow. So inspecting without having to bring it into port or dry dock?
Precisely. These innovations are becoming required, in a sense, because they allow for safety oversight and essential maintenance without the massive cost and downtime associated with traditional dry docking. Think about concepts like the Hydrex Mob Dock for doing underwater repairs.
That's clever. Saves a lot of time and money.
It does. Now, here's perhaps a note of caution that has to temper all this enthusiasm for the new tech.
Okay.
Our sources reveal a potentially significant risk in how training assessment is sometimes handled.
Training for these new systems.
Yes. While companies implement thousands of online courses, which is great for access, the quality of the assessment often lacks robust monitoring. It's quite easy to record a high training completion rate.
But much harder to truly gauge competency. Do they actually learn it?
Exactly. Do they understand it well enough to apply it under pressure?
And that lack of true competency verification, well, that feels like a massive hole in the safety net, doesn't it?
It really does. If an incident happens later, there's a serious danger that damage or injury is instantly mislabeled as just human error.
When the root cause might actually have been a faulty training model, one that failed to properly verify understanding, even though it issued a digital certificate saying complete.
Right. The RS really needs to address this assessment standard head-on somehow. It's critical.
Absolutely. So summing up this massive undertaking we've been discussing, the ultimate global piloting tool, this RS, it's defined by 3 pillars that are totally inseparable.
Okay, let's recap them.
First, meeting audience needs primarily by reducing that cognitive burden and actively promoting good bridge resource management.
Got it. Pillar 1.
Second, implementing robust technical requirements. That means seamless sensor integration, using standard protocols like NMEA, getting all that data flowing reliably.
Pillar 2, the tech.
And third, maintaining strict, continuously evolving safety standards, things like GMDSS, dynamic inspection models, and hopefully better training assessment.
Right. Audience, tech, safety.
Inseparable.
Exactly. The future of navigation, sometimes framed with that concept of connecting the dots.
Yeah.
It really requires synthesizing the high-tech solutions.
Like ECDIS, remote drones, those efficient Y-hybrid propulsion systems.
Synthesizing those with high-reliability operational practices, like clear SOPs and effective teamwork.
Okay. So given the increasing sophistication and really the interconnectivity of all these digital systems on the bridge, here's a provocative thought we want to leave you with today.
As the RS evolves, as it demands ever more complex tools and integrations, how does the industry ensure that the continuous training assessment model truly verifies the proficiency and competence of seafarers in managing these systems?
Rather than just recording a successful click-through completion.
Precisely. How do we know they really know it? That feels like the core challenge standing between a paper specification, however good, and true, tangible safety at sea.
That question of verifiable competency, yeah, it's perhaps the most important requirement of all, isn't it? Thank you for joining us for this investigation from the podcast from OOTO TV.
We certainly hope this provided you with the foundational knowledge you needed about the global piloting specification. It's a complex but vital area. Until next time.